a times a gives me a squared. A times b gives me ab. B times a gives me ba, but I can also write that as ab. I'm just going to write it in alphabetical order. And b times b is b squared. Now, again, I'm going to combine like terms and put it over here and do it vertically. So I have a squared plus 2ab plus b squared. And I'm going to multiply that by another a plus b. If I multiply this through, again, we need to understand what we're allowed to combine and what we do when we multiply bases that are the same. B times b squared is going to give me b cubed. B times 2ab is going to give me a positive 2ab squared. B times a squared is going to give me a squared b. I leave my gap, and it's going to give me like terms. And then I'm going to go ahead and start multiplying my a through. So a times b squared is ab squared. And it's positive. A times 2ab is 2a squared b. And it's positive as well. And then a times a squared is a to the third power. Now if I combine my like terms that are stacked up, I am going to get a cubed plus 3a squared b plus 3ab squared plus b cubed. Now, what we're going to do in this next part is actually what people used to do before these magical things called calculators came about. If they wanted to find something that was outlandishly big to the third power, they couldn't just punch it in the calculator and get the answer. What they did is they used this, and we'll learn more about what this is actually coming from here in just a moment. But for the third power, we'll use this to calculate 11 to the third power. Now, if I want to calculate 11 to the third power using this same thing, I'm not going to call it 11 to the third power. I'm going to call it 10 plus 1 to the third power. And odds are, if I think about this, I can probably do this using mental math. And again, this is more where this came in handy. So I'm going to slide up here slightly so that we can work this out and you guys can see what I'm talking about. So if I plug 10 in for a, I'm just going to plug it in. 10 to the third power plus 3 times 10 squared times 1 plus 3 times 10 times 1 squared plus 1 squared. And I could do all of this using mental math, you guys. So again, this is where this really came in handy way back before calculators. So if I work this out, 10 to the third power is going to be 1,000. 10 squared is 100. Times 3 is 300 plus 1 is 301. 3 times 10 is 30 plus 1 squared is just 1, so it's going to be 31. And finally, 1 squared is 1. So if I add this all up, let's see, I have 3 in the ones place. In the tens place, I have another 3. In the hundreds place, I have another 3. And in the thousands place, I have 1. So using mental math, we just solved 11 to the third power. Again, understand all I did was I took this value and I plugged it in for A, this value and plugged it in for B. The one thing to keep in mind is that you make sure that you do exponents first as you're going through those terms. So make sure that you're not misunderstanding what to do first on those exponents. Okay, so again, what they threw at us here are those other 3 patterns. We've seen the difference of perfect squares. So the sum and difference, if I FOILed this out, that'd be fine, and my middle terms would cancel. But we know that if I have a plus b times a minus b, my solution is going to be a squared minus b squared. So if I use that same formula for a squared would be 16n squared minus b squared. B is 5, so it's going to be minus 25. And that is my solution. I am done. Okay, it's not quite the same for these next two, but these next two are pretty similar. If it says minus in the middle, it's going to factor into a squared minus 2ab plus b squared. So if I use this pattern, 9y squared is going to give me 81y squared. And then 2 times 9y is 18y times another 2 that's in the formula. 18 times 2 is going to give me negative 36y. And then b squared is going to be plus 4. So again, all I'm doing, if you guys listen to me, if you need to rewind or whatever, I'm trying to save some time due to my restrictions that I have, but think about what I'm plugging in there. I'm just plugging this in for A, this in for B. Next one is the same thing, except for it's slightly different. It's going to be A squared plus 2AB plus B squared. My A in this scenario is AB. So AB squared would be A squared B squared. You square both terms. And then 2 times AB, they're trying to make this confusing, times B is going to be plus 8AB. And again, that's kind of a mouthful. And then B squared, pardon me, it's going to be plus B squared is just going to be plus 16. And that's what you would get if you use those patterns that we saw a couple pages ago. Once again, you guys, these are practice for you guys. Go ahead and try them. I'll write this out here in just a moment so that you guys can see what your solutions would be. Okay, so again, if you haven't really done these, I would pause and back up and at least try a couple of these. I'm going to read through them kind of quickly. The work is all here, so if you have any questions about something you may have done wrong, look over my work. You'll have to excuse that it gets a little crammed at times, but I'll leave it here for just a moment while I talk through it, and then I'll slide down and kind of talk through the rest. As you do 3, 4, and 5, again, you're just multiplying polynomials, which is what we did earlier on. So you'll, for number 3, you see you'll get 8x to the third power plus 6x squared minus 9x minus 5. Number 4, 5y to the third minus 7y squared minus 7y plus 2. And number 5, you'll get m to the third minus 7m, and there is supposed to be a plus sign there, plus 6. So I'll move on down. You guys can see what's going on here. Pardon me, whoops, there we go. For number 6, you should get 9t squared minus 4. Again, it's just one of those patterns. Number 7 and 8 are also those patterns. Number 7, you get 25a squared plus 20a plus 4. Number 8, xy squared, or x squared y squared minus 6xy plus 9. Number 9 asked us in the first part to prove that a minus b to the third power is equal to a cubed minus 3a squared b plus 3ab squared minus b cubed. You can see the work for it there. And then it asks us to use that to find the value for 9 to the third power. So instead of writing 9, I wrote 10 to the third power, and you guys can see the work there. You should get 629. Again, take the time, make sure you guys are trying these, ask questions if you have them. Okay, so as that a plus b or a minus b to the nth power climbs, really where that came from was this guy Pascal, and what he wanted to do was be able to figure out numbers to really high powers. Again, this is long before there were calculators, so in order for you to find these numbers that everyone knew existed and you to be able to do them using mental math, he came up with this pattern, and this pattern works, again, as you can see there, to the nth degree, but you could essentially take a number to an infinite power and should be able to find that number's answer. So if you take a look here, here are the first 6 rows of Pascal's triangle. Obviously the first row, it's kind of pointless, you see there, but if you go to the 0 power, you're going to get 1, because anything to the 0 power is 1. If we have just to the first power, again, when it's just the first power, essentially that means it's just those 2 terms. But as it climbs, you guys can see the patterns start to develop on the right-hand side. And essentially what it does is it takes your variables that are your a's and they work their way down as b kind of gradually takes over. So if you have a to the 5th power, your next one will be a to the 4th, a to the third, second, first, and so on. So there's a to the 0 power, it's gone. And then if you look at it as a perspective for b, it's going to be b to the 0 power, which is nothing, or 1, then b to the first, b to the second, b to the third, and so on. So you can see there the numbers, though, are what is really useful to us, that Pascal kind of did for us. You see that it's giving us those numbers that we need to multiply by once we use those A and B patterns in our triangle. So, of course, now that we know Pascal's triangle, we're going to go ahead and try and use it. I'm going to copy down the pattern from the previous page down so that you can see what it is as I work it out. And you guys, I advise that you copy down that pattern in notes because I certainly can't memorize it. Okay, so again, all we're doing is basically plugging in values. So for A, X is A and 2 is B. Now, we have a -2, so we have to watch that. When we're multiplying through, you'll see some sign changes. So if I plug in, I'm just going to plug in and then I'm going to solve for the second step. So x to the 5th plus 5, x to the 4th times -2 plus 10, x to the 3rd times -2 squared plus 10 x squared times -2 cubed plus 5 times x times -2 to the 4th plus -2 to the 5th power. So now if I do all this math, x to the 5th is going to stay the same. 5 times -2 is -10, x to the 4th. -2 squared is +4, times 10 is 40, so plus 40 x cubed. -2 to the 3rd power, this one should say. -2 to the 3rd power is -8, times 10 is -80 x squared. And then -2 to the 4th power is 16, times 5 is plus 80x, and then -2 to the 5th power is -32. So there's that answer, and that's all the farther you can simplify it. I wrote the pattern down for the second one. We're going to go ahead and plug in here to solve. So 3y to the 3rd power, and I'll write it out like this to begin with, plus 3 times 3y squared, 3y squared times 1 plus 3 times 3y times 1 squared plus 1 cubed. 3y to the 3rd power is going to be, whoops, not 9, but 27y cubed. 3 squared is 9 times another 3 is plus 27y squared, because that 1 really isn't going to do anything. Plus 3 times 3y is 9y, times 1 is still just 9y, plus 1. So there you have it. Again, guys, when it's expressions that you're writing out, it doesn't seem like it was too useful for him to create that, but keep in mind what they were probably trying to do is probably trying to find something like 215 to the 17th power, and using his triangle he could do those patterns and find stuff like that. When it's expressions, this stuff is just showing me that you guys know the properties and can use the patterns. So for the grand finale, try these two, and I'm going to write out the solution here in a couple seconds and you guys can look them over. Alright, so again, I didn't really show out the work because it would have taken up too much space, but you guys, if you have questions, make sure you ask. But I did just plug them into the Pascal's triangles and you guys can look them over. If you didn't get that, or if you got just 1 or 2 terms wrong, odds are you did most of it right. You might have just taken something wrong with an exponent, or you may have had a sign error somewhere, so keep eyes out for that. Thank you for your patience in this long video, you guys. We had a lot of material to cover. Good job getting through it.